percent yield. Sometimes in laboratory, a side reaction might occur, or you might spill some of your sample, or the reaction doesn't go to completion, something else happened. This is when we can talk about our percent yield. In chemistry, we would like to go, if we're in industry, we'd like to go up to our boss and say, I had this much reactant plus this much reactant, and I got all the product that I could possibly make. That generally doesn't happen. What'll happen is that you go up to your boss and say, I have this much reactant and this much reactant, and I made 98, 95% of what I possibly could make. And your boss is like, that's great. Other times you come up, this much reactant, I only made 4%. That's when you know something has gone wrong. So what is this percent yield, these reaction yields? How do we deal with this? Well, first off, we're going to need to calculate a theoretical yield. And we'll talk about this more in class and work through a lot of problems in class as well, but we're just going to introduce the concept here. What is a theoretical yield? It's the amount of the product calculated. This calculated is an important word here, using the molar ratios from the balanced equation. So what that means is we're going to have a theoretical yield, and our theoretical yield is going to be predicted based on the amount of starting reactant. We can go through our balanced chemical equation and convert that reactant, those grams of reactant, to moles of reactant, then convert it to moles of one of the product, and then to grams of the product. Once we know how to do that, and we've done this before in class on Tuesday, we can predict exactly how much or the total maximum amount of product that we can produce. That's called your theoretical yield. Now our actual yield is going to be the amount that we produced in laboratory. What that means is when we come across problems, you're going to be given two numbers generally. The first number is going to be an amount of the reactant. The second number is going to be the amount of a product that you collected. The amount of the product that you collected is called your actual amount. That's what you produce by going into the laboratory. You can only find an actual amount by running the experiment in a laboratory. So theoretical yield is predicted using mathematics. Actual yield is obtained by weighing out the sample in a laboratory. Since we can't be in a laboratory all the time, I will be giving you some of these actual yields. Some students get confused with the theoretical and the actual yield. Which one is which? Remember, theoretical yield is calculated. If you're using your mole-to-mole ratios in the balanced chemical equation, that is going to be considered your theoretical yield. Great. We have theoretical, we have actual. How are these two things put together to produce a percent yield? The actual, okay, in this case, yeah, the actual yield is usually less than the theoretical yield. That's because you generally will have spillage, or some of your crystals won't transfer over correctly, or there was a side reaction or something happened. So you'll generally get a percent yield less than 100%, and that's what this statement says. If the actual yield is less than your theoretical yield, you'll have a percent yield less than 100%. What that means is we can create an equation. Our percent yield, like I said at the beginning of this slide, I would go up to my boss and say 97%, 92%, 4%. The percent yield is equal to a very simple equation. It's the actual yield, so the amount that we obtained in laboratory, divided by the theoretical yield, which is the amount that we calculated using the mole-to-mole ratio of the balanced chemical equation, times 100%. So of course our percentages, we generally multiply by 100%, in order to get our units to work out there. So we're going to be working a lot of these types of problems. The percent yield is a very universal number that we deal with in chemistry. Industry uses it all the time. The government uses it quite a lot because they want to know, if I do perform this reaction, how much product can I possibly expect out of it? If it only produces a 4% yield, we know that that's not a very viable reaction. We would have to go to something else. We want a percent yield closer to 100 to make sure that all of the reactants are used up. So this is your idea, the first implementation of our percent yield reaction yield. Now what happens when you have your actual less than your theoretical? Well, there's lots and lots of things that can happen. Sometimes here we have our reactants, they're working together. Sometimes you forget to clean your beaker, and what will happen is you'll get a side reaction. and something in your beaker will react with one of your reactants, and you'll get a side product. This product generally is not counted or will not be counted when collecting your final sample. And so part of your reactants are moved to the side and you lose some of them. So that's one thing that can happen. This will give you a percent yield less than 100. Another thing that can happen is you can be like me in a laboratory and be clumsy and accidentally spill some of your sample. If you spill some of your sample, your theoretical product is going to be much higher than your experimental product or your actual product, which means you're going to have a very low percent yield. And this happens to me quite a lot in lab. On the flip side, if you have a percent yield that's higher, that's greater than 100%, it generally indicates that you have an impurity in your sample. You've added water to your sample, or you've collected some dirt that fell into your beaker. I know it shouldn't happen, but it does. So if you're above 100%, it generally means you have impurities in your sample. If you're below 100%, it means that you've lost some of your sample. And if you're at 100%, you're probably lying. It's very, very, very hard to get a 100% yield in chemistry. It rarely happens because you're transferring all these compounds around, things are sticking to the side of the beaker. It's almost impossible to get a perfect transfer from one beaker to another. So this is your idea, or our idea, of these percent yields. So we have limiting reactants and we have percent yields. They kind of go hand in hand.